So dear friends, welcome to today's episode of online problem solving session for JAM and NET aspirants, which is organized on behalf of math aspirants WhatsApp groups. This is the 15th episode of our program. Today we have a prestigious resource person, Miss Rosna Paul, with us. She is now doing Ph.D. at Graz University, Austria. She is excelled throughout her studies. She completed her M.Sc and MPhil from Cochin University of Science and Technology, and she secured JRF in 2018. And she is the first rank holder for both BSc and MSc. And he has got so many research fellowship and scholarships like Inspire Research Fellowship, Kerala State KSCSTE Research Fellowship, and Inspire She Scholarship. I would like to thank Ms. Rosna for accepting our invitation to join with us. Hope that today's sessions will be really a fruitful session, and moreover, it will be an inspiring for our students, because possibility for doing PhD at some outside India and all that. So it will be really, your students will be really blessed to have such a wonderful personality as our resource person. Once again, I welcome all of you to this session.
Okay.
Yes.
So for the today's section, I will be dealing with the linear algebra problem solving. Is it still okay? Is there any echo?
No problem. Now it is perfectly okay.
Okay. So for this section, I'm dealing with linear algebra. As a first part, to refresh our memories, I would like to give some definitions which we'll be using for problem solving. So first part, we will be dealing with some of the theory. I'm not going to any proof, but just going on to some results that we are going to use in our problems. And I think it will last around 30 minutes. Then we will move on to problem solving. So in the beginning, I will just go through some of the results, and then we can move on to problem solving. Okay, so I hope that everybody know what is vector space is. So I will start with the linear transformation. Let V and W be two vector space over the field F. Then a function from V to W is said to be a linear transformation if it satisfies two conditions. The first condition is that T of V plus W is equal to T of V plus T of W. And the second condition is that T of lambda V is equal to lambda of T of V. So this is the scalar multiplication, and this is the addition, where V and W are the elements of the vector space and lambda is a scalar. So if you want to calculate, if you want to check whether the given transformation is a linear transformation is not, there are several methods. This is the first method by checking it separately, or you can combine it together. Like here, that T of lambda 1 V1 plus lambda 2 V2 is equal to lambda 1 T of V1 plus lambda 2 T of V2. Or if you want to simplify a little bit further, you can use this equation, that is T of lambda V plus W is equal to lambda into T of V plus T of W. And if we have a linear transformation from V to V, that is from same vector space to same vector space, it is known as linear operator. And a linear transformation from V to F is called the linear functional. And the another important thing is that the linear transformation is determined by mapping the basis elements of the vector space V of X. So if you know where the basis elements are mapped to, then it is enough for a linear transformation. So we can derive the whole mapping of the vector space from the basis elements. And another important thing related to a transformation is the range of the function T. So range of linear transformation T is the collection of all elements T of V, where V belongs to V. This is a subset of our codomain W, and this is a vector space. And kernel of T, which is also known as the null space of T. This is the collection of all V belongs to V, such that T of V equal to 0. So it is the collection of all vectors which is mapped to 0. This is a subspace of our domain V. And the dimension of range of T is always less than or equal to dimension of V. There is a special name for the dimension of range of T. We call it as rank of T. And there is a special name for the null space of T or the kernel of T. Its dimension is known as the nullity of T. So concerning this rank of T and nullity of T, we have a theorem which is called the rank nullity theorem. Which says that if we have a transformation from V to W, a linear transformation, then dimension of the domain is equal to the rank of T plus the nullity of T. So this is a very important theorem. We are using this theorem in many problems, so please remind this theorem. And I have given some notes, and these kind of questions might ask in some of true or false kind of questions, or maybe in some options. So it is good to know this one. That is, if T is a linear transformation from V to W, then T is onto if and only if rank of T equal to dimension of W, and this T is 1, 1 if kernel of T equal to only the set 0. And let's see a question. Which is a very simple question. I just wanted to make sure that you understood the definition of rank and nullity. Let T be a linear transformation from V to V, so it's a linear operator basically, such that T score equal to 0. Then the first option is rank of T is less than or equal to nullity of T. The second option is rank of T is equal to nullity of T. And third option is rank of T is greater than or equal to nullity of T. And fourth option is none. So do you know, do you have any idea how to solve this? Or if you know which is the answer, could you type it on the chat? If you understood the definition of rank and nullity, I hope you can try it. Is anybody trying? Actually, I couldn't see anything in the chat. Is anybody typing? Okay, there are correct answers coming there. Okay, then I will just go through the answer for those who didn't get it. So we have T score equal to 0, which means that T of X equal to 0. So here we can consider the, I can again hear my echo. Is somebody turned on?
No problem. No problem, Rosna.
Okay.
Some people are answering in the comment section. You can go through that also.
Yes, I'm seeing it. Let me explain this. So we have T score equal to 0. Then we can write it as T of X equal to 0. But we know that T of X is an element of the range space R of T. So if you take an element of range space of R of T and apply the operator T, you will get 0. Which implies that the elements of R of T is also the elements of the null space of T. Then you will get R of T is a subset of N of T, hence the rank of T is less than or equal to nullity of T. So the option A is true, and most of all have given that option A is true. So I hope that everybody understood the topic. And let's see one more question. I should not show you the answer. Let T be a linear transformation from V to V. Is it possible to see the whole question? Okay. Let T be a linear transformation from V to V, where V is a finite dimensional vector space, such that rank of T is equal to the nullity of T. Then what can you say about the dimension of V? We know that dimension of V is a finite number. So I'm asking about, is there any special property for the dimension of V that you can deduce from this question? Yeah, there are correct answers. Very good. So I will just explain it for others. Yeah, Diya, Rekshita, and Shubh, everybody is saying the correct answer. Very good. So we have the rank nullity theorem, which says that rank of T plus nullity of T is equal to dimension of V. But here, the rank of the rank of T and nullity of T are the same. So 2 times rank of T is the dimension of V, which implies that V is an even number. Dimension of V is an even number. So the answer is correct. And now let T be a linear transformation from V to W. Then it is called a singular linear transformation if kernel of T is not equal to 0, which means that there should be at least one non-zero vector which is mapped to 0. And a transformation T from V to W is called a non-singular linear transformation if kernel of T is equal to 0. So the only 0 element is mapped to 0. And the next topic is very important, which is the metric representation of linear transformation. In this case, we are taking a linear transformation from V to W, where the dimension of V is considered as n, and the basis is taken as V1, V2 up to Vn. This is an ordered basis of V, and the dimension of W is considered as m, and we are taking the basis V2, which is W1, W2 up to Wn. Now the matrix of T with respect to the basis B1 and B2 is denoted by this one. We are mentioning on which basis we are writing T, and this will be a matrix of dimension m cross n. And what are the elements of this matrix? The first column will be the linear expansion of T of V1 with respect to the basis V2. The second column is the linear expansion of the second basis element V2, the image of the second basis element with respect to the second basis, and so on. Okay. And here, if you are taking the transformation from same vector space to same vector space, that is, if you are taking the linear operator, we might not write it as the two bases. We will write it as only with one basis. And let's see an example to make sure that you understood the topic. Let T be a linear transformation from P3 to P3. So here I am considering P3 as a polynomial of degree at most 3. So the general element in this topic, in this vector space will be of the form A0 plus A1x plus A2x plus A3x cube. And here I am defining the linear transformation as P of x is mapped to its derivative. So polynomial P of x is mapped to P dash of x. So how we are attacking this problem? First, we consider the basis of P3, which is 1x, x squared, and then x cube. And we are looking at the elements to which it's get mapped. So first element is 1, and we are taking the derivative, you will get 0. And the second basis element is x. We are taking its derivative, you will get 1, and so on. So x squared is mapped to 2x, and x cube is mapped to 3x squared, and so on. And now we are expanding each of these images with respect to the basis of the codomain. But here it is also P3. And one thing you have to be sure that you are expanding it in the order of this ordered basis. So this is an ordered basis. You are not allowed to shuffle the elements. So you have to expand it in this order. So for T of 1, it is very easy to see. It's 0 into 1 plus 0 into x plus 0 into x squared plus 0 into x3, which gives you the coefficient vector as 0, 0, 0. And for T of x equal to 1, the only change you will get is here there is a 1. So you will get another vector, column vector here. For Tx squared, it is 2x. While expanding, you will get 0 to 0, 0. And for T cube, you will get 3x squared, and this is expansion. Now collect all these column vectors together, and that is your matrix. So since it is from P3 to P3, P3 has dimension 4. It is a 4 by 4 matrix. I hope this is clear. And this is one of the simple and very important topic in linear transformation. So if you have a transformation from V to F, and if the dimension of V is n and the dimension of W is m, always we will get a matrix of dimension m cross n. This is a very important thing because in some cases we can eliminate the options by just looking at the dimension of the matrix. And a matrix M is called a singular matrix if the determinant of A is equal to 0, and the matrix is called non-singular if the determinant is not equal to 0. Now, this is another method of problem solving. So, suppose that you are given with some collection of vectors, and we know how this vector, is expanded with respect to the basis. So, let B1 be a vector, and A1, A2 up to AN are the coefficients you obtain by expanding it with respect to the basis, and V2 is another vector which is who has coefficients B1, B2, Bn, and up to Vm. And if somebody asked you to find the dimension of the linear space spanned by these vectors, and there is an easy method to find the dimension. What is that? First, construct a matrix A by taking these elements as column. Then you will get an M by N matrix. Then find the row reduced echelon form of A, and the number of non-zero rows is equal to the dimension of the space spanned by these vectors. Okay. If I'm going very fast, you can comment it, or if you didn't understand something, please comment it on the chat. So I hope that this is very easy. So let's try to solve this problem. This is actually asked in a GATE examination. Let V be a vector space of real polynomials, and W is spanned by t squared plus t plus 2, t squared plus 2t plus 5, and 2t squared plus 2t plus 5. Then the dimension of W is, there are 4 options. Option A is 4, option B is 3, option C is 2, and option D is 1. So I think these are simple questions. You can answer it on the chat, and we can check whether the answer is correct or not. Nobody is answering? Is it difficult, or are you just calculating? Yeah, for the row reduced case, I think you might need a little bit more time for getting the row reduced matrix. There is one answer from Akshara. I'm not saying whether your answer is correct or not. I'm just waiting for others to answer also. Yeah, 2, 3, option B, yes. Okay, most of you got the answer as correct. The answer is 3, that is correct. So how you get is, I take the first vector, and here I'm taking the ordered basis as t square, t, and 1. So that is the order I took. So it is 1, 1, 2. You will get 1, 1, 2. I mean, in the column or row, whatever it is, and 1, 2, 5, and 2, 2, 5. So you will get 1, 1, 2, 1, 2, 5, 2, 2, 5. And this is the matrix you obtained. Now you find the row reduced form. You will get 1, 1, 2, 0, 1, 0, and 0, 0, 1. This is a row reduced form, and every row has a non-zero element. So the dimension is 3. So your answers are right. Very good. So this method also helps us to find the matrices with same row space. For example, if you are taking the vector space as Rn, and if you have 2 subspaces which is spanned by V1, V2 up to Vm, and the other subspace spanned by W1, W2 up to Wk, and if A and B are the corresponding matrices, and we reduce these matrices into A dash and B dash, then if A dash and B dash are equal if and only if the corresponding vector spaces are same. So by using this idea, we can find out the matrices which have the same row space. For example, I will give you a problem. So, which of the following matrices have same row space as the matrix 484, 361, 240? Then we have option A, B, C, D, and this is also an easy question. I'm expecting your answers in the chat. So here we only need to collect the rows which are non-zero. Okay, D has answered. Yeah. Nanda has answered. Okay. Alina shook here. So these answers are right. You are getting the point. Very good. So I will just show you. I am taking the matrix and I just take the row reduced form and I just collect the non-zero rows. You will get 1, 2, 0, 0, 0, 1. I just checked with which of the options are same. So option A is the same. So what we have just shown before is that if you have two matrices whose row reduced form are equal, then they have the same row space. So these are the two matrices which have the same row space. So option A is true. Yes, Bala Subramanian, yes. Everybody got the correct answer. Very good. And now a rank of a matrix is the number of linearly independent columns, and which is same as the number of linearly independent rows. And this is also equal to the number of non-zero rows in the echelon form. If you asked to find the rank of a matrix, it is enough to reduce it to a reduced echelon form and to count the number of non-zero rows. So for the above example, we know that the reduced form of this matrix is A. So it has only two rows of non-zero elements. So the rank of this matrix is 2. And there are some other important results related to rank of a matrix. If you have a matrix of size m cross n, then the rank of that matrix will be always less than equal to minimum of m and n. And if you have a matrix A, and if you multiply with a constant k, which is not equal to 0, then rank of Ka is equal to rank of A. And this is very important result. You should remember it always because it is very useful. This says that if you have a matrix A of dimension m cross n and a matrix B of dimension n cross p, then rank of A plus rank of B minus n is this common one, this n, is always less than equal to rank of AB. Okay, now let's solve a question in a gate, which is appeared in the net examination. Sorry. Let A be a non-zero matrix of order 8 by 8 with A square equal to 0. Then one of the possible values of rank is option A is 5, option B is 6, option C is 4, and option D is 8. So I'm just asking about the possible values of rank of A. Yeah, there are some answers coming. Actually, the option C, Alina Thomas, Timmy Baby. Yeah, you are getting the correct answer. That is true. How you obtain this? We have A square equal to 0, and we know that the relation connecting A and A square, which is rank of A plus rank of B, which is also A here. So rank of A plus rank of A minus the dimension 8 is less than or equal to rank of A square. This is 2 times rank of A minus 8 is less than or equal to 0. Taking 8 to the other side, you will get 2 times rank of A is less than or equal to 0, and rank of A is less than or equal to 4. So rank of A can be at most 4, so it can be 5, it can't be 6, it can't be 8. The only possibility is 4. So option C is correct. Yeah. And this is the another important topic in linear algebra, that is the eigenvalues and eigenvectors. Let T be a linear transformation from V to V. Then a scalar lambda belongs to F is said to be an eigenvalue of T if there exists x belongs to V such that x is not equal to 0, such that T of x equal to lambda of x. And this lambda is known as the eigenvalue of T, and this non-zero x is known as the eigenvector of T corresponding to lambda. Now, let W lambda be the collection of set of all eigenvectors corresponding to lambda, and we are adding 0 together because in the set of all collection of eigenvectors, there won't be the element 0 because we are taking the non-zero vectors. So if you add the 0 together with this set of all eigenvalues corresponding to lambda, you will get a subspace, and this subspace is known as the eigenspace corresponding to lambda. And the dimension of W lambda, that is the dimension of the eigenspace corresponding to lambda, which is equal to the number of linearly independent eigenvectors corresponding to lambda, and it has a special name. It is called the geometric multiplicity of lambda. Now the other result is if A be an n by n matrix, and let T be a transformation from Fn to Fn defined by T of x equal to A of x, and lambda is an eigenvalue of T. This happens if and only if Ax equal to lambda of x. So we can replace this T and A if it's a corresponding matrix. That is the result which is given here. And the next result is eigenvectors corresponding to distinct eigenvalues are linearly independent. Sometimes this kind of result is asking as an options in the C-part questions. So it is good to remember these things. Okay, if A is an n by n matrix, then the characteristic polynomial of A is the determinant of A minus lambda I, and the degree of the characteristic polynomial is n. The roots of the characteristic polynomials are called the eigenvalues, and there is a result that if you're if you're calculating the characteristic polynomial of A, this is same as the characteristic polynomial of A transpose. And there are some more results concerning to the eigenvalues. There is an easy method to find the eigenvalues of upper or lower triangular matrices or the diagonal matrices. For these kind of matrices, the eigenvalues is its diagonal entries. So you don't have to check the roots of the characteristic polynomial. You can directly find it from the matrix. And this is another important result, which seemed to be very nice, but it is very useful. If lambda is an eigenvalue of A, then if P of lambda is an eigenvalue of P of A for any polynomial P. So if we have a polynomial P, and if you have a matrix which is obtained by substituting the value of A into it, then the eigenvalue of this matrix is nothing but P of lambda if lambda is an eigenvalue of A. And there is another important result concerning the characteristic polynomial, that is the Cayley Hamiltonian theorem. I hope that you all know this. Every matrix satisfies its characteristic polynomial. And another concept corresponding to the polynomials of the matrix is the minimal polynomial of the matrix A(n) cross n, which is denoted by minimum of A of x. This is the smallest degree monic polynomial that satisfies A. And if P be any polynomial such that P of A equal to 0, such polynomials have a special name. We call it as annihilating polynomials of A. So we are actually killing A with this polynomial. So these are the annihilating polynomials of A. And we have a result that if P of A equal to 0, so if P is an annihilating polynomial of A, then the minimal polynomial of A divides the annihilating polynomial. And since every characteristic polynomial is an annihilating polynomial, the minimum polynomial of A also divides the characteristic polynomial. And there are some cases of minimal polynomial if minimal polynomial of A equal to 0, if and only if A is a 0 matrix, and a minimal polynomial of A is x raised to k if and only if A raised to k equal to 0. And such matrices have a special name. These are known as the nilpotent matrices. And let T be a linear transformation from V to V, then minimal polynomial of T is defined as the minimal polynomial of the metric representation of T. So if you know the metric representation of T and the minimal polynomial, then that is same as the minimal polynomial of T. And since we have see before that the minimal polynomial divides the characteristic polynomial, and from that we can conclude that the minimal polynomial of A and the characteristic polynomial of A have same root except the multiplicities. And I'm just going to some other topic. I'm not going to explain much. I'm just explaining it because I am included one problem related to this. Another topic is the system of linear equation. Suppose that we have a system of linear equation of this form, like a11 x1 plus a12 x2 up to a1 and xn, which is equal to b1, and we have the system where aij belongs to the field f. This field can be complex number or real number and so on. Then we collect the coefficients from here, and it is known as the coefficient matrix A. And then we collect the variables here. It is denoted by X, and we collect the B1, B2, B3, and we call the matrix B. So A is an M by N matrix, and X is an N cross 1 matrix, and B is an M cross 1 matrix. And the above equations can be represented by Ax equal to B. If B equal to 0, we get it as a homogeneous system of linear equation. And if B is not equal to 0, this is known as non-homogeneous system of linear equation. And if you want to solve this equation, we need another concept of augmented matrix. It is nothing but you take the matrix A and you add one more column of B. And this is known as the augmented matrix of this equation, and it is denoted by A colon B. And here we need only one result for solving our problems. That is, if Ax equal to B has a solution, if and only if rank of the augmented matrix should be equal to rank of A. So these are the some of the results we are looking at. Now we can go to the problem solving. I think you are okay with these results? Okay, let's go to the problem. So let's go to the first problem. Let T be a linear transformation from R2 to R2, given by T of xy is equal to minus of xy. Then the first option is T power 2k is equal to T for all k greater than or equal to 1. The second option is T power 2k plus 1 is equal to minus T for all k greater than or equal to 1. And option C is the range of T square is a proper subspace of range of T. And option D is range of T square is equal to the range of T. So I will give you some time to think about it. If anybody knows the answer, please write it on the chat box. I'm getting some results. Okay, anyway, let's move on to the solution. You can answer it if you get an idea of it. Okay, to solve this problem, we are using the metric representation of T with respect to some basis of R2. For example, let's take the basis B as 0, 1 and 0, 1. I mean 1, 0 and 0, 1, which is the standard basis of R2. Now, how you write the metric representation of T? So first you evaluate T on 1, 0. So we have minus xy, so minus 1, 0, and expand it with respect to the same basis. So minus 1 into 1, 0 plus 0 into 0, 1. And for the next basis element, apply the operator 0, 1. So it is 0, 1 again. So it is 0, 1, 0 plus 1 into 0, 1. So we get the vectors as minus 1, 0 and 0 and 1. So we get minus 1, 0 and 0 and 1. So this is the matrix corresponding to T. I'm just calling it as T itself. So what will be T square? Is it easy to multiply? So you will get T square as 1, 0 and 0, 1. So thus we have T as minus 1, 0, 1 and T square as 1, 0, 0, 1. So from here, since it is an identity matrix, T raised to 2k, I'm multiplying it, I'm taking the power as k in the both sides. You will get T raised to 2k is equal to the identity matrix power k, which is nothing but I, for all k greater than or equal to 1. And if you want to find T raised to 2k plus 1, multiply the t raised to 2k into t. So t raised to 2k is, we have already find it as I into t, which is equal to t for all k greater than or equal to 1. For in this case, the option A is false, because it was given that t raised to 2k is equal to t. No, it is equal to 1. And t raised to 2k minus 1 equal to minus t. No, it is t. So option A and option B are wrong. Okay. Now let's check the other options. So here there is an nice property of t square. Here t square is equal to t. This is an involutory matrix. But if you don't know this name, it's fine. It's not that much relevant. So first of all, you have the matrix T, and it was given by minus 1, 0, 0, 1. So you know the rank of the matrix T is 2 because the number of non-zero rows is 2. The rank of operator is 2 because it is a representation. So the range of T is full of R2. And the similar way, here this is an identity matrix, so rank of T square is also 2. The range of T is full of R2. So we get the range of T square is equal to range of T. So option D is correct. Is that clear? Yes, okay. Let's move on to the next question. Let M be a real 6 by 6 matrix. Is it visible to you? It was written as 2 and minus 1. Let 2 and minus 1 be two eigenvalues of M. If M raised to 5 is equal to A into identity matrix plus B times M, where A and B are real values, then there are four options. Option A says that A is equal to 10 and B is equal to 11. Option B says that A is equal to minus 11 and B is equal to 10. Option C says that A is equal to minus 10 and B equal to 11. Option D says that A is equal to 10 and B is equal to minus 11. So I will give you some time for this one. So what we have a real 6 by 6 matrix. So, and two eigenvalues are given. And we have one equation on this matrix, that is M raised to 5 equal to AI plus BM. Yeah, and Mary, Shuk, yeah, they have answered the questions. Very good. Let's see whether we will get any other different answer or the same answer. Vishwajit, yes. Just try something. Yeah, just now. Tino, Ajina. I hope that you are getting Alina, Tia. Yes, very good. Okay, for those others, I'm just explaining how you will get answers. So their answers are right. It is answer A. So we know that M is a 6 by 6 matrix. So it has at most 6 eigenvalues, counting multiplicities. And the characteristic polynomial of M has two roots because the eigenvalues are the roots of the characteristic polynomial. So it has two roots as 2 and minus 1. And we know that the minimal polynomial of M and characteristic polynomial of M will have same roots. Multiplicities may be different, but they have the same roots. So 2 and minus 1 are also the roots of the minimal polynomial of M. And let P of x denote the characteristic polynomial of degree 6. And we have the equation that M raised to 5 is equal to AI plus BM. So I'm writing it as a polynomial by taking everything to one side. So you will get x raised to 5 minus B of x minus A equal to Q of x. But this is an annihilating polynomial because if you substitute M here, you will get 0. And we have already seen that minimal polynomial divides every annihilating polynomial of M. So the roots, since a minimal polynomial has root 2 and minus 1, so it will be also the roots of this polynomial. So you will get Q of 2 equal to 0 and Q of minus 1 equal to 0. Then Q of 2 is equal to 32. I mean, if you are substituting 2 here, 32 minus 2b minus a, which is equal to 0. And Q of minus 1 is minus 1 plus b minus a. So you got two equations in two unknowns. You can solve it. And you will get a is equal to 10 and b is equal to 11. So now option A is correct and you have guessed it correctly. Very good. Now let's move on to the next question. Let M be an n by n matrix where n is greater than or equal to 2. This is a non-zero real matrix with m square equal to 0. Let alpha be any real number which is also a non-zero number. Then option A, alpha is the only eigenvalue of m plus alpha I and m minus alpha I. Option B, alpha is the only eigenvalue of m plus alpha I and alpha I minus m. Option C, minus alpha is the only eigenvalue of m plus alpha I and m minus alpha I. And option D, minus alpha is the only eigenvalue of m plus alpha I and alpha I minus m. So in this case, you only want to find the eigenvalues of m plus alpha I, m minus alpha I, and alpha I minus 1, alpha I minus m, and see which of them are same. And we have some ideas for that because it is given that m square equal to 0 and m is a non-zero real matrix. So can you try to get the answer? There are some answers coming. Alina, Jitu, Shiranya, Tinu, yes. All of them are getting B. Let's check whether that's the answer. Is anybody else wants to try? Just now. Bhagyasri, CSIR Dec, Mathematical Wall of Beauty. Yes, good. Ashwati, okay. Okay, I think you are getting the answers. Let's check whether it is right or not. So it was given that m is not equal to 0 and m square equal to 0. So one of the annihilating polynomial is x square, which is q of x because m square equal to 0. And we know that the minimal polynomial of m divides annihilating polynomial. So now we are using this result several times. So this is an important result. The minimal polynomial of m divides q of x. So what are the possibilities? The only possibility is x and x square. We know that if the minimal polynomial of the given matrix m is equal to x, then it should be equal to 0. But this is not the case because m is a non-zero real matrix. So the only possibility for the minimal polynomial of x is it should be equal to x square. Now, the roots of the minimal polynomial and characteristic polynomial of the matrix are the same. So the roots of minimal polynomial is 0 because the minimal polynomial of x square is equal to 0, which implies the roots are 0. So the eigenvalues of m are 0, 0, 0. 6 roots are there, so 0, 0, 0, 0, 0. Now we have to check whether what will be the eigenvalues of these matrices. How do you check that? We are using the result that if the eigenvalues of a matrix m is k, then p of k is the eigenvalue of the matrix p of m, where p is a polynomial. Now, for the first case, I'm taking the polynomial p as x plus a. Then if you substitute m, you will get m plus ai, that is this one. Then the eigenvalues of p of m is of the form k plus a. Why? If k is the eigenvalue of m, then p of k is the eigenvalue of p of m. So p of k is k plus a. And since we know that the eigenvalues of m are 0, so these k's are 0. So the eigenvalue of p of m is equal to a. So here the a is, you can treat it as alpha. So for m plus alpha I, its only eigenvalues are alpha. In the similar way, you can consider a minus alpha I and an alpha I minus a. Here you have to take the polynomial as x minus a, and this is a minus x. And if you substitute the values, you will get this as minus alpha and this is alpha. So which of the polynomials have the same eigenvalues? So one is m plus a alpha, which has the eigenvalue alpha, and a times I minus m is also have the eigenvalue a. So they have the same eigenvalue, and that this is only eigenvalue. So the option B is true. So you have said the correct option. Very good. Now let's go on to the next problem. Let M be an 4×3 real matrix, and let E1, E2, E3 be the standard basis of R3. Which of the following is true? The first option is, if rank of M equal to 1, then the collection ME1 and ME2 is linearly independent set. Second option is, if rank of M equal to 2, then the collection ME1 and ME2 is a linearly independent set. Third option is, if rank of M equal to 2, then ME1, ME3 is a linearly independent set. And D, if rank of M equal to 3, then the collection ME1, ME3 is a linearly independent set. So can you try to solve this problem? There are answers. B, C, D, B, C. Bhagyaশ্ree asked me a question, but I did not understand. B, C, D. I think some of them are confused with the answers. Okay, I will just try to solve it step by step. Then you will get more idea. So let's consider some examples to see whether it is working or not. Nitish, Vishwajit, okay. Some of them are getting answers, okay. Okay, let's focus it here. Consider some examples. In the first case, I took the matrix M as 1, 0, 0, and all other rows are 0, because for the option A, I want a matrix of rank 1. So this is clearly a matrix of rank 1. I have multiplied it with, so what I need to find whether these vectors ME1 and ME2 are linearly independent or not. So I'm taking the matrix M and multiplied it with E1, I get 1, 0, 0. And now I again multiply it with E2. But here in this case, when I am multiplying, I get 0, 0, 0. So now we have the collection 1, 0, 0, 0 and 0, 0, 0. So if we have a 0 element in our collection, it is always linearly dependent. So option A is wrong. And let's see, if I take M as this one, 1, 0, 0, 0, 1, 0. Here I got the first multiplication as 1, 0, 0 and second multiplication as 0, 1, 0, 0. So can I conclude that option B is true? Because I got two linearly independent vectors, right? This is and this matrix is linearly independent. Can I conclude that this set, the option B is true? No? Okay. Does anybody think that it's true? Okay. Yeah. A lot of people are saying it's wrong. Yeah, you are right. It is wrong. If I get a matrix which gives the linearly independent set, it doesn't imply that the option B is true. This is actually a trap. So while we are constructing examples, what have to do is you should always search for a counterexample. Otherwise, you have to prove it. Just one example satisfies this condition doesn't mean that it is true. So this kind of examples might be misleading you. So you have to be careful and you have to find the counterexample. So let's see how to construct a counterexample. So here what happened? When I put a 1 here, I got 1, 0, 0. And when I put it here, if you multiply this 0, 1, 0 with 0, 1, 0, you got 0, 1, 0, 0. that is how I got this linearly independent set. So can I do some manipulations here and make it as a linearly dependent set? So one way why I got one here, it is because this one is get multiplied this with this one. So I just trying to push this one to this position or this position. So consider the case this one. I am pushing this one to here. But what happens, I will get 1, 0, 0 and again 1, 0, 0, which in turn give the rank of the matrix as 1. But I need the rank of the matrix as 2. So it is not good to put it here. So now push the 1 to here. So you will get 1, 0, 0, 0, 0, 1 and so on. And if you multiply this 0, 0, 1 together with this vector 0, 1, 0, you will again get 0, 0, 0. So that is what happened here. Now you will get this set as a linearly dependent set. So option B is also false. Okay, is that clear? So now I explained how you find the counterexample. So what will be the counterexample for C? So if you put that one back to here, as we took it wrongly for B, then we also get it as 0, 0, 0. So this is again becomes a linearly dependent set. So option A is wrong, option B is wrong, option C is wrong. So if you have three options, if you have four options and first three are wrong, so the only possibility is D is correct. But for the completeness of the program, for the problem, I would like to give why D is true. I mean, if you're solving the problem for examination, if you didn't have much time, you can stop it from here. But since it is, I think it is good to explain why option D is true. Let's go there. So what we know that M is a 4×3 matrix. So it can be considered as a matrix representation of a linear transformation between two vector spaces V and W. So it is a 4×3 matrix, implies that the dimension of V is 3 and the dimension of W equal to 4. So somebody has mentioned this in the chat. I didn't read it completely, but I hope that he mentioned the same thing. Okay. So from this, we have the rank nullity theorem that dimension of V is equal to rank of T plus nullity of T. Now, dimension of V is what? It is 3. 3 is equal to rank of T plus nullity of T. If rank of M is equal to 3, which means that the corresponding transformation also have the same rank. By the rank nullity theorem, T is 0. Why? Because if you put 3 here, the only possibility of nullity is 0. That is, none of the non-zero vectors could be mapped to 0. So T of E1 is not equal to 0 and T of E2 is not equal to 0, which in turn gives you that ME1 is not equal to 0 and ME3 is not equal to 0. So if you're taking the collection ME1 and ME3, none of the elements are 0. But it doesn't gives you that the set is linearly independent. We have to establish it. Now, if possible, assume that this ME1 and ME3 are the linearly dependent set. That is, it will be of, I mean, we can write it of the form ME1 plus ME2 is equal to 0 because they are linearly dependent. And we know that ME1 is not equal to 0 and ME2 is not equal to 0. So this happens for some non-zero values of A and B. Now, what is ME1? ME1 actually corresponds to the first column of the matrix M, and ME2 corresponding to the third column of the matrix M if you are multiplying it. If you want to see it, so this is E1, ME1, what will you get? You are multiplying this to here, this to here, this to here. So only the first column is represented by this vector, and like ME3. So when you, since we have only one non-zero element here, it is represented by the last column. Okay, now ME1 is the first column of M and ME2 is the third column of M. And we have the relation that AME1 plus BME2 equal to 0, which means that the first column is a linear combination of a third column. So the first column is a linear combination of the third column, which means that its rank is less than or equal to 2. I mean, there is an equal to, less than or equal to 2, which is a contradiction. Why? Because we assume that rank of M equal to 3. Okay, is that clear? So if rank of M equal to 3, then the set is linearly independent set. Okay, now so the option D is the correct one. So next question is, consider the following system of linear equation: x plus y plus 5z equal to 3, x plus 2y plus mz equal to 5, and x plus 2y plus 4z equal to k. The system is consistent if option A, m is not equal to 4, option B, k is not equal to 5, C, m is equal to 4, D, k is equal to 5. So we have just so in the result section that how to check whether a system has a solution or not. Yeah, it might take a little bit time to calculate. I will wait for you. Yes, and I know your idea for the previous problem is also good. Is it option A? Akshara, Tino, Jasmine, Sharanya, Krishna. Let's see whether anybody else get a different answer or is A is true. Option A, B, D, option A and B. Option D. Option A. Okay, we are getting very different answers. So let's go on to the solution. So we have given a system of linear equation, and this can be converted into a matrix form, which I explained in the first section. You have the matrix A, which is coefficient matrix. So it is 1, 1, 5, 1, 2, m, and 1, 2, 4. That is the matrix A. And we have the coefficient, the variables as x, y, z, and B is equal to 3, 5, and k. A system is consistent if rank of A is equal to the rank of augmented matrix. So now construct what is the augmented matrix is. So we have already said how to construct augmented matrix. You take the matrix A and insert the column of B. Sorry for the disturbance of sound from my side. So we have take the matrix A and added a column B here. And now we want to find the rank of this matrix. So what is the easy method to find the rank? We had to construct, we had to take the row reduced form. So I made the column, first column, the first element as 1 and the following as 0. And the second column, I made 2 equal to 1 and the remaining elements down to it as 0. And I obtained a row reduced matrix here. Now we have to check the things by case. So for the option A, we have m is not equal to 4. So m is not equal to 4. This cannot be equal to 4. This cannot be equal to 0, which means that the rank of matrix A is equal to 3, and this K can be anything. It doesn't matter. Still, the rank of AB will be also equal to 3. So rank of A is equal to rank of 3. So in this case, option A is correct. Yeah. And what will happen if K is not equal to 5? That is the option B. K is not equal to 5. In this case, we don't know what happens to M. So suppose that if M equal to 4, if M becomes 4 and K is not equal to 5, so this is not a 0 element, but this can be a 0 element. If this becomes 0, then rank of A equal to 2. But since this K minus 5, this element cannot be 0, the rank of the whole matrix, the augmented matrix, is equal to 3. So the rank of A is not equal to rank of augmented matrix. So option B is false. Okay, I think it's clear. Now consider the case C. That is M is equal to 4. We don't know whether K is equal to 5 or K is not equal to 5. Let's check it. Suppose that M equal to 4. In that case, when you put M equal to 4, you will get 0 here. And suppose that K can be anything. So suppose that K is not equal to 5. So here you will get a non-zero entry, and here you will get a 0 entry. So when you consider the matrix A, it has rank 2. But if you consider the augmented matrix, this complete matrix, this is 0 and this is non-zero, which implies that the augmented matrix has rank 3. So rank of A is not equal to rank of augmented matrix. So the option C is false. Now let's consider the option D. If K equal to 5, that is the option D. If K equal to 5, M can be anything. M can be equal to 4 or not equal to 4. Suppose that M is equal to 4. So in this case, M equal to 4, this becomes 0. K is equal to 5, this becomes 0. Then the rank of matrix A is 2, and the rank of the augmented matrix is also 2 because these entries are 0. So rank of A is equal to 2, which is equal to the rank of augmented matrix. So the system is consistent. And now consider the other case, that is M is not equal to 4. If M is not equal to 4, then this is a non-zero entry. But K is equal to 5, this is a 0 entry. But if you consider the matrix A, since M is not equal to 4 and this entry is non-zero, you will get the rank of A is as 3, and the rank of the whole augmented matrix as also as 3 because there is a non-zero entry here. In this case, the system is consistent. So in this case, option D is also correct. So option A and D are the correct answers. I hope you understood this question. Option A and option D are correct answers. Okay, let's move on to the next question. Consider the real vector space P2020, which is the collection of summation from I equal to 0 with AI x raised to I. It's till to 2020. Summation I equal to 0 to n, where AI x raised to I, where AI belongs to R, and n varies from 0 to 2020. Let W be a subspace given by W is the summation of I equal to 0 to n, AI x raised to I belongs to this collection P2020, such that AI equal to 0 for all odd I. Then the dimension of W is, it doesn't have any options. I think it's appeared in the JOM examination in the numerical section, 2020, I guess. What will be the answer? Okay, there are some answers. I think you already wrote the exam or you find it from here. Vishwajit, Alina Thomas, yes. Let's wait for some others. Only 2 people. Okay, 3 people are answered. Sharanya. Nitish Kumar, yes, there are a lot of answers coming. Nitish Kumar, Vivek, Jisna. Pia. Somebody's right. Dimitula. Appear. Yeah, we got very similar answers. Okay, let's look at this question. So P2020 is the collection of all polynomials with real coefficients with degree at most 2020. So a general element in P2020 will look like a0 plus a1x plus a2x square up to a2020 x raised to 2020. So what will be the basis of P2020? It will be the collection of 1x, x square, and so on to 2020. So the dimension of P2020 is the number of elements in the basis, which is 1 plus 2020, which is 2021. Now what is W? W is the collection of all polynomials with coefficient of odd powers of x are 0. These are the subspace of P2020. So the general element of W look like a0 plus, there is no a1 term because the coefficient is 0, a2x square plus there is no a3 term, a4 x raised to 4 up to a2020 x raised to 2020. So in the similar way, what is the basis? It's x square, x raised to 4. Only the even powers will appear here. So the dimension of V is 2020 divided by 2. That is, if you're taking the pairs like x and x square as one pair, x3 and x4 as one pair. In the similar way, if you're taking all the pairs, we are taking only one among this pair. So 2020 divided by 2 plus 1, which is 1010 plus 1, which is 1011. So everybody got the correct answer. Very good. So the answer is 1011. So the next question is, let M be a matrix which is given by 9271, 0721, 00116, 00 minus 50. Then the value of determinant of 8i minus m the whole cube is dash. So this is also a numerical question. Okay, anyway, let's go to the solution. Let's see whether their answer is correct. Most of them are saying that it is minus 216. Let's see. So we have determinant of AB is equal to determinant of A into determinant of B. And also the determinant of A raised to n is equal to determinant of A the whole raised to n. So in this case, they are asked to find the determinant of 8i minus m the whole cube. So it is enough to find the determinant of 8i minus m, then take the cube of it. So now construct the matrix 8i minus m. So you have the matrix m here. If you do the calculation, you will get something like this one. And the determinant of 8i minus m is, you are taking the determinant as such. So it is better to take it with respect to this column because there are a lot of zeros. You will get minus 1 into this calculation. You will get it minus 6. And this is the determinant of 8i minus m. So determinant of 8i minus m is minus 6. You are taking the cube. You will get minus 216. So the minus 216 is the correct answer. This is actually one method of solving it. You can also find the determinant by using the eigenvalues. We know that the product of eigenvalues is equal to the determinant. If you want, you can also use that method. For that, it is easy to divide this matrix into block. And you can find the eigenvalues of this block matrix by finding the eigenvalues of this block and this block. So what you will get, this block is actually an upper triangular matrix. So we have already saw the result for the upper triangular matrix. If we have an upper triangular matrix, then the diagonal entries are the eigenvalues. So here the eigenvalues are 9 and 7. And for this block, this is a 2 by 2 matrix, and we have an easy formula for finding the characteristic polynomial of the 2 by 2 matrix, which is x square minus trace mx plus determinant of n equal to 0. This is x square minus trace is the sum of the diagonal entries, which is 11, and determinant, it is minus 30. So x square minus 11 minus 30, and you will get the eigenvalues as 6 and 5. So what are the eigenvalues of the matrix M? The eigenvalues of matrix M are 9 and 5, and from here you will get 6 and 5. So if you have the eigenvalues of the matrix M, and this can be considered as a polynomial like 8 minus x. So before we have, so that if we have a polynomial which have M as the variable, then P of lambda will be the eigenvalue of that. So if you're considering the polynomial as 8 minus x, then 8 minus 9, 8 minus 7, etc. will be the eigenvalues of this one. So you will get minus 1, 1, 2, 3 as the eigenvalues of 8i minus m. So what is the determinant? Determinant is the product of eigenvalues, which is minus 1 into 1 into 2 into 3, which is minus 6, as we got before. And determinant of 8i minus m, the whole cube is actually minus 6 the whole cube, which is minus 2 and 6. So this, I am just given two different ways to finding the answer. So both gives the same solution. It is minus 2 and 6. Yes, most of you answered this correctly. Very good. Now, the another question is, if A and B are 3 by 3 real matrix, says that rank of AB is equal to 1. Then rank of BA cannot be, option A is 0, option B is 2, option C is 1, and option D is 3. Okay, Vishwajit, Needu, Jesse. Priya, Ramya, Priya, Rishad Kumar, Ikshita, Jyotsna. Okay, a lot of people are getting similar answer. Let's check whether the answer is right or not. So we have A and B as 3 by 3 matrices. So in this case, since it's a square matrix, so AB and BA is, they are also 3 by 3 matrices. Given that rank of AB is equal to 1, which implies that the determinant of AB is equal to 0. So rank of AB is equal to 1 means we have only one row of non-zero elements, and hence the determinant of AB can be considered as 0. And we also know the determinant of A into determinant of B is equal to determinant of AB. So since determinant of AB equal to 0, either A or B or both should be equal to 0. And also, what will be the determinant of BA? It is also same as determinant of A into determinant of B. So this term is equal to 0. So determinant of BA is also equal to 0. So which implies that BA is a singular matrix. And we know that BA is a 3 by 3 matrix. This implies that it cannot have the rank 3. So it has a rank less than 3, then only they will have the determinant equal to 0. So the rank of AB cannot be equal to 3. So the question is, what can be the rank of, what cannot be the rank of AB? So option D is correct. Yes, you all said the correct option. So this is an easy question, I guess. Okay, let's move on to another set of problems. For that, I will go in this way. So this question is actually taken from CSIR Dec question paper. The previous questions are mostly taken from IIT JAM. So let's see this question. Let Q be, the question Q, sorry. Let C be a collection of vectors 1, 2, and 2, 1. And this is actually a basis of R2. And let T be a linear transformation from R2 to R2 be defined by T of xy is equal to x plus y and x minus 2y. If T of C represents the matrix of T with respect to the basis C, then which among the following is true? We have options 1 as minus 3 minus 2 3 1. This is 3 minus 2 minus 3 1 minus 3 minus 1 3 2 and so on. So please try this question. This is just finding the metric representation of T. It might take a little bit time for calculating. I will wait. Amy, Tina. Only 2 people have answered. Okay. Rakshita, 3 people. Okay. Vishwajit, everybody is getting the same answer. Good. Is anybody else trying? Okay, there. Lena. Tia. Everybody got the same answer. Very good. Okay, let's try to solve it. For those who are still trying to check this answer later. As in the same way, let T be a transformation from R2 to R2, and it is given by T of xy is x plus y and x minus 2y. And we have the basis as 1, 2, and 2, 1. It is just substitute this basis here. So when you put 1, 2 in the transformation, it's mapped to x plus y, which is 3, and x minus 2y, 1 minus 4, which is minus 3. And we have to expand it with respect to the basis 1, 2, and 2, 1. For that, we just put a into 1, 2 plus b into 2, 1. You will get it as a1 plus 2b, which is equal to 3, and 2a plus b, which is equal to minus 6. So we get a set of equation here. And the similar way, if you put the values as 2, 1, in the transformation, you will get x plus y, which is 3, and 2 minus 2y, which is 0, so 3, 0. We also want to expand it with respect to the same basis. So it is a into 1, 2 plus b into 2, 1, which is a plus 2b, which is equal to 3, and 2a plus b, which is equal to 0. Now we get the another set of equations. By solving one, we get a equal to minus 3 and b equal to 3. The corresponding vector is minus 3, 3. And solving 2, we get minus 1 and minus 2. We get the vector minus 1, 2. So which gives minus 3, minus 1, 3, 2. So the option 3 is true. Okay, so everybody, Samshila, yes, everybody got the same answer. Very good. And this is a similar question. No, sorry, this is a different question. I thought it is also from linear and the metric representation. No, but you can try it. Yeah. Let W1 be the collection of vectors UVX, UVWX. This is a 4 tuple in R raised to 4, which satisfies the condition that U plus V plus W equal to 0, 2V plus X equal to 0, 2U plus 2W minus X equal to 0. And W2 is a collection of 4 tuples which satisfy the equation U plus W plus X equal to 0, U plus W minus 2X equal to 0, V minus X equal to 0. Then which among the following is true? Option A, dimension of W1 is equal to 1. Option 2, dimension of W2 equal to 2. Option 3, dimension of W1 intersection W2, I couldn't also see it, equal to 1. And option 4, dimension of W1 plus W2 equal to 3. So this is the question. Femi Akshara. Associate. Is anybody else answering? I think only 3 people have tried it just now. 3 and 4, Bhagyashree. Akshara says that 1 and 2 of course. Let's check. Nitish Kumar. Okay, let's check the answers. Nitish Kumar. Okay. So what we have for W1, it is the collection of 4 tuples with U plus V plus W equal to 0 and 2V plus X equal to 0. From the first equation, U plus V plus W, you will get W is equal to minus U minus V, and from 2V plus X equal to 0, we will get X equal to minus 2V. So for W1, it is the collection of n tuple U, V, W, X, and W can be replaced by minus U minus V, and X can be replaced by minus 2V. So this is the general, this is a form of a general element in W1. Here we can see only 2 variables. So if you put the first variable as 1 and second variable as 0, and then the first variable as 0 and second variable as 1, you will get 2 elements. So this will give the basis of W1. This is 1 0 minus 1 0 and 0 1 minus 1 minus 2. So these are the basis of W1. Hence the dimension of W1 is equal to 2. But in the question, it was given that the dimension of W1 is equal to 1. So option 1 is wrong. Now for W2, we have that U plus W plus X equal to 0 and U plus W minus 2X equal to 0. By combining these two equations, we get X equal to 0. And we have another equation that V minus X equal to 0. By substituting X equal to 0, we get V equal to X equal to 0. And by putting this value x equal to 0 back to this equation, you will get u plus v equal to 0, which implies u equal to minus v, or you can write w equal to minus u. So for w2, the general element in w2 is of the form u v w x, but v equal to 0, w is minus u, and x equal to 0. The general element will look like this. So the basis element is 1 0 minus 1 0. So it contains only one basis element. So the dimension of w2 is equal to 1. But we have in the question as dimension of w2 is equal to 2, which is actually wrong. Now we have to see what happens to the dimension of w1 intersection w2. So in order to solve this problem, it is actually, you don't need to find the basis element. You can solve it by looking at here, because there are only two variables. All the other variables are depending on these two variables. So the number of independent variables is equal to 2 here. And in this case, there is only one variable available. So the number of independent variables is 1. But when you want to find the intersection, I mean dimension of the intersection of the subspaces, it is easy to calculate it from the basis. So here the basis element is 1 0 minus 1 0 and 0 1 minus 1 minus 2, and here it is 1 0 minus 1 0. So you have a common one element in the basis. So the intersection will contain the common basis element. So the intersection of w1 intersection w2 is equal to 1. And otherwise, if you don't want to calculate the basis, then you can see that the W2 is the collection of U0 minus U0, and W1 is the collection of UV minus U minus V and minus 2V. If you put V equal to 0 here, then you will get U0, which is same as U0, minus U minus U, and then 0. So we can say that the elements of W2 is actually contained in elements of W1. That is, the W2 is a subspace of W1. So in that case, if you take the intersection, W1 intersection W2 is equal to the W2, which has dimension 1. So these are the two methods that we could calculate. Either you can look at the general elements and see whether one is contained in another, or you can write the basis and find the intersection of their basis. In both cases, you will get W plus W1 intersection W2 equal to 1. And the last option was what happens if the basis, the dimension of W1 plus W2. We have that W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. So we know what is the dimension of W1, which is 2, dimension of W2 is 1, their intersection has dimension 1, so you will get 2. So in the question it was given that dimension of W1 plus W2 equal to 3, but it is actually 2. So only one option is correct, that is option 3. Is that clear? Because some of the candidates have got different answers. So I hope that now it's clear. Okay, very good. Thank you, Akshay. Now let's move on to the next question. Let A be an n by n complex matrix. Assume that A is self-adjoint, and let B denote the inverse of A plus In. Then all eigenvalues of A minus In times B are, first option, they are purely imaginative. Second option, of modulus 1. Third option, they are real. And fourth option, of modulus less than 1. So for this question, I give you a hint. I think you can try some examples. That will be more easier to eliminate some of the options. And thank you, Priya and Sanjida. Yeah, it's clear. Thank you. Thank you so much. I will give you some time because you have to find some matrices as a counter examples. But take very simple examples. Don't go for very complicated ones. Take very simple examples and check whether it gives real numbers or purely imaginative. And always remember that when you take the examples, it doesn't mean that one thing is true, but we can only consider it for the counter examples. Amy, Rakshita. That's it. Only 2 people have answered, so I think I will wait for a little bit long for others' answers. Sunita. Chitu. They are getting different answers. Akshara and Mary. So people are getting doubtful in the answer. Okay. So let me explain what it is. So we know that A is an n by n complex matrix, and it is given that A is self-adjoint, which means that A is equal to its conjugate transpose, and B is the inverse of the matrix A plus In. Now, for the first and fourth option, consider the zero matrix. Let's take A as a zero matrix, then clearly it is self-adjoint. We consider B, and what we have to find is A minus In times B. So A minus In times A plus In, the whole inverse. Since our matrix A equal to 0, this is minus In into minus I into identity matrix, the whole inverse. This inverse will give you 1 by I and In inverse, but the inverse of the identity matrix is again the identity matrix. And when you calculate this, you will get minus In. So for this matrix, if you put A as a zero matrix, then the eigenvalues of A minus In times B, you will get it as -1, -1, and so on. So this is not purely imaginative, and this is of not modulus less than 1. So we got a counterexample for option 1 and 4. For option 3, consider the matrix as In, I mean the identity matrix. So identity matrix is self-adjoint. Then you will get A minus In into A minus In inverse. You substitute A as In, and you can take this 1 minus I outside. So 1 minus I times In of 1 plus I times In whole inverse. The inverse will give you 1 divided by 1 plus In. And when you calculate this one, you will get minus I. I hope that you know how to calculate this one. You have to take the conjugate of it and multiply the numerator and denominator. You will get minus In. So what is the eigenvalues of this case? It is minus I times the identity matrix. So the eigenvalue, when you take A as the identity matrix, is minus I, and so on. So these eigenvalues are not real. So option A1 is wrong, option 3 is wrong, and option 4 is wrong. So the only option correct is the option 2. Okay. Now let's consider the next question. Consider the linear operator L from R2 to R2 defined by L of P of t is equal to P of t plus 1 minus P of t. The matrix L in the standard basis 1t square is the following. Which of the following is the matrix representation of L? So here the R2 of t is just a representation of set of all polynomials of degree at most 2. Let's wait for the answers. Okay, Tinu, Samshila, Nitish, Ansa, Jisna, Akshara, okay, Priya, Alina, very good. Now I'm getting a lot of answers. Akshita, Pushpajit, I think you really like the matrix representation of the transformation. Mridula, yes. Okay, I hope most of you know this one, Sharanya. Then I will just go through the answer very quickly. So here we have a linear transformation from polynomials to polynomials defined by L of P of t is equal to P of t minus 1 minus P of t, and the base is already given as 1t square. So what we will do, we will take each of the cases. First, we take the polynomial as the constant polynomial 1, and then we apply the transformation. So the transformation is polynomial at t minus 1 minus the polynomial at t. Since it is a constant polynomial, the value will be always 1. So 1 minus 1 equal to 0. You will get the first vector as 0, 0, 0. The easy way to solve a competitive exam is that check which of the options have the first vector 0, 0, 0. So here, yeah, in this case, we are so lucky. We got only the option A has the first vector as 0, 0, 0. Actually, if you're doing the problem for the competitive exams, you can stop it here and mark the option A, because this is the only possible one among the others. But for the completeness of the problem, I will just give you the whole thing. But in order to save time for the competitive exam, you just analyze the options and mark the correct one. So for P of t, for the next case, I have to take the polynomial as the second basis element, which is t. So P of t plus 1 minus P of t is t plus 1 minus t, which is equal to 1. Now we will get the vector 1, 0, 0. And for the third basis element, that is t square, you have to we have to map t square. Then you will get P of t plus 1 minus P of t, that is t plus 1 the whole square minus t square, which is t square plus 2t plus 1 minus t square, which is 2t plus 1. Expand it with respect to the order of the basis. So that is why I mentioned that you have to remember the order of the basis. Don't write it as 2, 1, 0 or something. It has to be expanded with respect to the order of the basis. So it is 1, 2, 0. So you will get 1, 2, 0. Then write the matrix 0, 0, 0, 1, 0, 1, 0, 0, 1, 2, 0. So it's option A. Yes, everybody is right. Sharanya, Purisho, Princy, yes, very good. All of you got the correct answer. And now move on to next question. This is also a metric representation, but here the difference is that they have given two different bases. So let T be a linear transformation from P3 to P2. So polynomial of degree at most 3 to polynomial of degree at most 2, defined by T of P of x is P double dash of x plus P dash of x. Then the matrix representation of T with respect to the bases 1x x square x cube and 1x x square of P3 and P2 respectively is the following. So if you write down the transformation already, I hope that you can write down the transformation. P double dash of x plus P dash of x. Then I can show you the options. So these are the options. So once again, the transformation is P double dash of x minus P of x. So we have We have some answers. Alina, Tinu, Dia, Sanshila, Prisha, Dia. Just now, Akshara is Abhiyat Vishwajit. I think you have got the idea of this kind of questions. Nitish, Ashwati, Baiju. Good, Jasmine. Balasubramanian. Yeah, since everybody got the answer, let's go to it. The first of all, let's look at the options. That is why I showed it explicitly to you. We have a transformation T from P3 to P2. Then what will be the size of the matrix? It will be 3 cross 4 matrix. In the options, the first matrix is 4 cross 3. No, it cannot be our option. And the D is also 4 cross 3. It cannot be the option. So the only possibility is either the option B or option C, because we have to be 3 by 4 matrix. So for this case, consider the first element, P of x equal to 1. It is, we have to find P double dash of x which equal to 0 and P dash of x which is also 0. So the element, the polynomial P of x equal to 1 is mapped to 0. So the first column is 0, 0, 0. So we have already deleted some options and we have only 2 options left. And among them, the first option has the column as 0, 0, 0. So option B is true. Yes. Rudula, Rakshita, yes, everybody have the same answer. Very good. And if you want, you can solve it for other basis element. Actually, for the completion of the problem, you have to solve it. But in the case of a competitive exam, you won't get time to solve everything. So you might need to use some of the techniques. So I think I will skip this thing because it's just a repetition. I hope that everybody already know how to do this. So option B is true. Good. And the next question, it looks a little bit lengthy, but if you read the question, you can understand that this is also the matrix transformation. So why I included some questions of matrix transformation is that this type of question is actually very simple to do and you will get the answer very quickly. But the formulation of question can be different. In the first case, you just given a one basis and you have to get a square matrix. And the second case, they have made a little bit twisting by giving 2 different bases so that you will get confused whether I use the first basis or the second basis. I have to expand it with respect to the first one or second one. So these kind of confusions may happen. So if you know the correct theory, then you will be fine with all these questions. And this is the third type of problem. Here they have included some integration. So when you first saw the question, you might feel that, okay, there is some integration and the question seemed to be very complicated. So let's skip the question. So please don't skip any of the question. First, just go through the question and see whether you can understand it. Maybe the question will be very simple. You know, the metric transformation is actually very simple. But the formulation of the question can be seem to be complicated, but actually it's not complicated. So this is the question for so I have included a similar question with the intention to show that the same idea can be asked in different ways. They might make it more complicated, but don't get confused. You have to do a very small amount of work and you will get the correct answer. And these kind of questions can be asked in the C-part section of NET examination, which will give you 4 points. So, which is nice, right? You just have to find the matrix of this transformation and you will get 4 marks. It is really a nice question, but don't get tensed by seeing all these integration things. So what is this question? Let P and denote the vector space of all polynomials with real coefficients and of degree less than or equal to n, equipped with the standard basis 1x x square up to x raised to n, defined by T is a transformation from P2 to P3, and it maps P of x to integral 0 to x P of t dt plus P dash of x, the first derivative of x, and evaluation of the polynomial at 2. So this is the transformation we have. Write the matrix of this transformation with respect to the standard basis of P2 and P3. So I will just give you the solutions. I'm sorry I couldn't put both of them in the same screen. So can you write down the transformation? It is the integral 0 to x from P of t dt plus P dash of x plus P of 2. And these are the options. So we already got a lot of answers. Let me check. Yes, Nidhi, Shalina, Tini, Nidla, Krishna, Manasa, Shalina, Kushu, Tia. Okay, yes, everybody got the same answer. Very good. Yeah, option D is correct. You are right. And I'm not solving it again because this is the same method. I will just show it on one case. I mean, I'm taking the polynomial as P of x equal to 1. Then T of P of x is integral 0 to x. 1 dt plus the derivative is 0 plus evaluating at 2 is also 1. So if you take the integral 0 to x dt plus 1, you will get x plus 1. It is 1, 1, 0, 0. So here is the whole calculation, but I don't think that you need whole thing here. So the first column is 1, 1, 0, 0. Let's check which one has this column. Okay, we have to make sure that this has the same ordering. So 1, 1, 0, 0 you will get here. And why this, if you are curious about why this half coming, it is because of this integration. So in the case, if you take P of x equal to x, you have to integrate with 0 to x t dt, which gives you x square by 2. That is the half we are getting here. So it is 1, 0, 0, 3, 0, half 0. So 1, 0, 0, 3, 0, half 0, and so on. So it is option D. So everybody answered this correctly. Very good. Let's quickly go to the next question. This was asked in the JUMP 2019. If 2yz is a vector where y and z are the elements of R, it's a real number. It's an eigenvector corresponding to a real eigenvalue of a matrix 0, 0, 2, 1, 0, minus 4, 0, 1, 3. Then z minus y is equal to dash. So you have given with an eigenvector corresponding to some real eigenvalue of the matrix. We don't know which eigenvalue is, but they are asked to find z minus y. Can you quickly answer the question, or do you need more time? I think we are almost reached the time. Should I to move on, or do you want to answer? Okay, for this question, I will just start the solution because we don't have much time. Okay, we know that the characteristic polynomial is the determinant of a minus lambda I. We just find out what is a minus lambda I and find the characteristic polynomial. So you will get this one as the characteristic polynomial. If you substitute 1 here, you will get the value as 0, which implies that lambda equal to 1 is a solution. And now you just factorize it as lambda minus 1 into other polynomial. And the second polynomial gives the complex root. From this, you can conclude that lambda equal to 1 is the only real solution. And in this problem, this has a special matrix. So in this case, if you got a characteristic polynomial, something like this, and you don't know what is the solution and you don't have much time to find the solution, then this is the matrix. So this matrix has an important property that the column sum is equal to 1. So if either the column sum is equal to some constant or the row sum is equal to some constant, then that will be an eigenvalue of the matrix. So from that also you can conclude that lambda is eigenvalue, but it doesn't gives you that this is the only eigenvalue. For that you need to split this. So at least you will get at least one eigenvalue here. Now by definition, what is the eigenvector? So eigenvector is the vector x such that a minus lambda equal to 0, put lambda equal to 1, and it is given that what is the vector x is, that is 2yz. So you just substitute it, you will get this one, minus 2x minus 2 plus 2z equal to 0, 2 minus y minus 4z equal to 0, and y plus 2z equal to 0. Now by equating these equations, you will get the value of z and y. It is asked what is the value of z minus y, which is 1 plus 2, which is equal to 3. Yes. Yeah, Bishwajit, the answer is correct. It is 3. Okay, let's move on to another problem. Let T be a transformation from R7 to R7 with the nullity of T is equal to 2. Then the minimum possible value of rank of T square is H. Akshara, yes, I could share this PDF to Vinod sir. I think he can give it to the WhatsApp group or somewhere, or the mail ID. Alina, Vishwajit, okay, they have given 3 as answer. Yes, their answer is right. For that, I will just go here, and because in the first section I have to put something else. Okay. Here we have the identity, that is rank of A plus rank of B minus n is less than equal to rank of AB. And you can consider this matrix A as a matrix representation of some linear transformation T from Rn to Rm, and B as a matrix of some linear transformation S from Rp to Rn, and St as a linear transformation, the combination of this linear transformation. In that sense, we can write R of T plus R of T minus n is less than or equal to rank of T square. But we already know that, so in the question it was given that nullity of T is equal to 2, but from the rank nullity theorem, we know that the nullity plus rank is equal to the dimension of the space. The dimension of the space is 7, and the nullity is 2, which implies rank of T is 5. So 5 plus 5 minus 7 is less than or equal to rank of T. So 3 is less than or equal to rank of T square. So the minimum possible rank is 3. That is right. So the same question, what will be the maximum possible rank of T square? In the same question, how can you find the maximum possible rank of T square? So what is your answer for that? Tino 5, good. Yeah, I will just show that also, how you could find the maximum. So the first case, if x belongs to, in this case we have okay, if x belongs to the null space of T, then T of x equal to 0. And if you again operate T on T of x, you will get T of 0, which is equal to 0. So which implies that whenever x belongs to the null space of T, then it also belongs to the null space of T square. So nullity of T is less than or equal to nullity of T square. And in the question it was given that nullity of T is equal to 2. So 2 is always less than or equal to nullity of T square. And by rank nullity theorem, the rank of T square plus nullity of T square equal to 7. And we have known that the nullity of T square is greater than or equal to 2 which if you substitute here, which gives that rank of t square is less than or equal to pi. So the maximum possible rank of t square is less than or equal to pi, which was correctly answered by Ashwati Balasubramanian Nidishiyas. Very good. Do we still have time, or should I stop here?
Hello, Rosna. We need some
Yes.
time for interaction, so I think it is better to finish with this or the next problem.
Okay, the next question is also just to find which of the following is the linear transformation. I don't know whether that might be elementary for them. Okay, then I will stop with the next question because it's simple. You can answer it easily.
Okay.
Which of the following is a linear transformation? So I have given 3 possibilities of the transformations, which is actually a linear transformation. Only F, only G, only H, or all of them. Let's see. Okay, only H. Somebody says B, H, C. Okay, anyway, the option, I mean, sorry, I written as both as option B. It might be confusing. Sorry, it's my mistake. The only H is correct one, because if you add 2 vectors, then you will get is 8. But if you want to take, for example, if you have 2 vectors, v1 and v2, therefore v1 plus v2 have the first entry as 4. But if you evaluate it separately, you will get 8. So they are different. So it cannot be a linear transformation. And for the second case, you need the multiplication. So for v1 plus v2, if you multiply, you will get a lot of terms. But if you take it separately, you will get only 2 terms. So they are also not equal. But for the option C, if you calculate lambda v1 plus lambda v2, you will get lambda f of v1 plus f of v2. So option C is true. Thank you. And anyway, I will share this PDF, so you will get the rest of the questions together with the solutions.
Okay. Thank you, Rosna.
Thank you so much.
You can stop the presentation. We will have a short interaction with the participants.
Let me see how I should stop it.
So, because
Okay.
then okay, good. Okay. Thank you, Rosna, for very informative explanations and the energetic and live interaction with throughout the program. The active participation students indicates that they are all very excited and happy with today's class. Now it is the time of interaction. Dear participants, you can talk with, you can ask your doubts, and you can share your comments with Rosna. Rosna is here. You can keep your audio and video on, and you can comment now.
First of all, I would like to thank you, Vinod sir, for inviting me and giving me this opportunity. And I also thank all the participants because they give a nice participation and they answer the questions very quickly. That is a nice sign if they are well prepared. I mean, well prepared actually. So thank you, everybody.
Okay, many people are responding in the chat box. Please do share your opinion by keeping video and audio on. You can directly interact. No need to go for chat box. Feel very free to talk with Rosna. I think we have some participants from your degree college, such Thevara. Some participants are there. Okay, I think.
Hello.
Yeah,
hello.
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 Hi, ma'am.
Ashwati, you can keep your on. Yeah,
yes,
Okay, am I audible?
If possible, keep your video also on.
Hello.
Yeah. Hi, ma'am. First of all, let me tell you, it was an absolutely beautiful class. It was really informative for us in every aspect of this linear algebra. Let me tell you very much a large thank you for you and
Thank you
Vinod
so
sir.
much.
So,
Ma'am,
Ashwat,
I have a doubt.
Yes.
Yes, sir.
Ashwati is from SH College Thevara and completed BSc and now got admission in Pondicherry University for her MSc.
Very good. Mhm.
It's really happy for me personally because you are in such a high position today
It's
from this
not
very
so high
different college.
position.
Okay, ma'am, I have a doubt. How can we obtain Inspire Fellowship actually? Because
Um,
now I'm an Inspire She Scholar. So,
mhm.
will this be helpful for me to obtain Inspire Fellowship or something?
Yes, there are two options for getting Inspire Fellowship. Either you should be the first rank holder, or you should be
Okay.
the Inspire scholarship holder. I don't know whether they have changed the rules currently, but when I was studying, these
Uh,
two people could possibly apply. And for that, you have to find a mentor or possible three
mhm.
mentors for your PhD and write a research proposal, and you have to collect some reference letter from them, and then you have to apply there. So
Okay.
in some case it is more easy to get it when you already got the PhD admission than applying
Okay.
before getting the PhD admission.
Okay. Okay. Thank you, ma'am.
Thank you so much.
Okay, thank you, Ashwati. We have some participants from CUSAT also. I think some of them will react. Possibly your juniors.
My professor is also here. I could see him.
Oh,
Hello, sir.
that, that is very nice. Hello, sir.
Hello, how are you?
Hello, sir.
Good, sir.
I would like to congratulate Dr. Vinod and yet to be become Dr. Rosna for such an event, because it's problem solving is always difficult, and a problem that you are able to solve at the age of 15, you cannot solve at the age of 50. I will
Yeah.
strongly recommend all of you to read the book by Terence Tao. You know, Terence Tao of University of California is a record holder in the mathematical Olympiad because he got successively bronze, silver, and gold. So he has a small book, very, very short book on problem solving. So there he has mentioned that at the age of 15 he could solve, but at the age of 50 he cannot solve. So problem solving is an art, and I think Rosna did a very good job.
Thanks,
So
sir.
I'm proud that she was a student of Cochin University. Good.
Thank you, sir.
Yeah.
Your presence is very inspiring for the students. And thank you very much, sir.
Thank you.
And yes, somebody's. Yes.
I have a doubt about Inspire Fellowship.
Mm-hmm.
Inspire Scholar now, and
Ramya, it will be better if you can introduce you.
For me, I feel that the audio connection is not clear.
Okay, Ramya, you just talk. Please, others. Many of them
Hello.
are keeping. Yes, Pallavi. Okay.
Yes. Hello,
Please introduce
Rosna.
yourself.
Hello, Rosna.
Hi. Yes.
My name is Pallavi, and I've just completed my masters in the previous June. I'm
Mm-hmm.
actually sitting for the coming net. So I want to thank you first. You really did a great job. Today's
Thank you so
sums
much.
were really helpful, I just wanted to ask, like, can you give some tips of how to speed up my sum solving? Because I mean, calculative parts sometimes take some time. So, can you tell me?
First of all, if you're answering for the competitive exam, you just check the options. Some of the
Uh-huh.
options you might not need to calculate everything. You can eliminate the option directly. So, for example, for
Okay.
the example we saw in the problem solving section, that if you are asked to find the matrix of the linear transformation, and if the matrix is given in a different dimension that is to be obtained, so you can easily eliminate them.
Uh-huh.
So these kind of options you can eliminate very fastly. And if you feel like some of the for the matrix, the computation is too long, you just solve it for a part of the options. I mean, if there are two
Okay.
options which are not similar and you can guess what the option is from the first set of columns or something, you just solve up to that. So you can save a lot of time, and always check the options before started solving, because some of the options can be easily cut out from the list. So I think
Okay.
that is the
Okay.
one trick.
Uh, can you recommend some books for linear algebra that are really help for problem solving?
I actually didn't take any books. I usually refer the main books like Kenneth Hoffman. But what I recommend is to do the previous question papers, solve the previous question papers, so you will get a pattern. I mean, at least you will get on which areas they are asking from. I mean,
Yeah.
the
Yes.
more asked
Okay.
questions. Then you can take the other sample question papers given by the other groups. I don't know which book is better,
Exams.
but other exams. And some of the books which have the solution for the CSIR net questions, they have some mistakes. I didn't find a book which has completely correct. There will be mistakes in the books. And I think as a first step, you just go through all the previous year question papers. That is the easiest one, and which gives you
Okay.
more confident. And always try to do the question paper with the time limit. Usually what I feel is that you might know the sum of questions, but you won't get time to complete it.
Yes.
So write
Yeah.
the
It might.
question paper. Yeah, that has also happened to me. I'm very slow in calculating things, so I will always try to do more questions before the net. And one thing I have to want to say is that net is also a part of luck. It doesn't mean that you study a lot, then you will get a net. But if you study a lot, there is high probability that you will get a net. But
Yes.
don't get worry about you are trying for several times and you are not qualifying. It's not because you are bad at doing things. No, there is some lucky factor in that. Actually, for me, it's not the first time. I mean, I just write 4 or 5 times, I guess. And
Okay.
in some part, I get depressed why I'm not qualifying net examination. But after all, somehow I cleared.
Okay.
So do
Okay.
not
So
lose your
persistence is
hope. You will
important.
get it. Yes, you will get it at some point. You will definitely get it.
Okay. Thank you.
You
Thank you a lot.
can
Welcome.
you can refer the book by Kumaresan. Kumarasan's book
Okay,
on
sir.
linear
Yeah.
algebra is lot of problems.
Okay. Okay.
Okay, thank you.
Thank you, sir.
Yeah, there is a different way of approaching the problem in combination circuit. Yes, that
Yes.
is true. Thank you for reminding me.
Okay, thank you, Pallavi.
Yeah.
Now others, please come forward. Don't miss this opportunity. You know, actually, Rosna's story is in all the way. It is really inspiring for all of you. So
Yeah, and if you are really hesitated to go abroad and to do PhD, I'm a best example. In the beginning, I was not that much convinced of the option of going abroad, and actually, it was the constant pushing from Vijaykumar sir that I reached here. And he also took his effort to convince my parents. So my parents was also not so much like the idea of going abroad. But when I came here, I felt like, okay, this is not a bad choice. This is really a good choice. So if you get a chance to go abroad and to do PhD there, it's a good option. And yeah, you won't regret it. No problem. I mean, you don't have to worry about it. Does anyone has any other questions?
Okay, others?
Good evening, ma'am. I'm
Yes.
Rosna. Well, now
Yes.
because yeah, I had the doubt about fellowship.
Sorry, I couldn't hear you correctly.
Ma'am, I wanted to know about fellowship, ma'am.
Inspire Fellowship?
Yes, ma'am. Because
Okay.
I'm getting Inspire scholarship now, and I'm doing my
Mm-hmm.
M.Sc final year. So I wanted to know how we get Inspire fellowship.
Yeah.
Like,
Yes.
so I wanted to know how we get Inspire fellowship, ma'am. Is it or any state level eligibility test?
There is no any eligibility test for Inspire Fellowship. You just have to apply for it, and they will evaluate you according to your research proposal and the possible research supervisors you are providing. So they evaluate according to that about the area and how much strong is your research proposal is, and how much your guide could support you. And they evaluate everything: the research proposal, your guide, and your area. So you don't have to clear any of the eligibility text or anything. I think there is no interview. I don't remember whether I had the interview, but I think there is no interview. It's just an application.
But the mentors from some they said that we have to clear NET in order to get a
For some university they have made criteria that you have to clear for NET examination, but there are still some universities which you do not need any NET, but instead you need a scholarship. So it can be either the JRF or any other scholarship. So I mean the fellowship. So Inspire is a fellowship. So if you are an Inspire fellowship holder, you are eligible to apply for it. You no need to clear the NET examination, but it varies according to the universities. You have to check whether there is any criteria for that. I think for Cochin University, you don't need it. For NITs, I don't think that you need NET.
Oh, yes. Thank you.
Okay, thank you, Ramya.
Thank you very much. Thank you.
Rosna, you can explain little bit the procedure how to get admission for PhD in abroad. That also can be. I think many people have that doubt.
Okay. First of all, you have to select your area, at least some areas you like. And if you are planning to do PhD in abroad, it is better to start with your when you are in M.Sc to get an idea of which area or which field you want to do. And in most of the abroad universities, for admission, they will ask you your master thesis. So if your master thesis is very much related to the area that you are applying for PhD, then you will have high percentage of getting it. So that is why I said that you have to think about it from the master's level. But it is not a compulsory thing. If you have enough courses attended or enough data to provide that you are interested in that area, you will get it. For my case, I have done the thesis on combinatorial commutative algebra, which is more related to algebra and combinatorics. But now I am working in more about symbol drawings of graphs. So it is more geometrical approach towards the graph. So only link I have between these two is that I have studied a bit of graph theory, but still I got the admission. So, but if you have a really good master thesis in the same area, then your chances are very high. But otherwise, also you will have chances. So, the one point I have to mention is that the master thesis is important. Master of MPhil thesis. I don't know whether MPhil is still available in India, but this thesis is important. And next is your referees. You should get your referee letter from them. So our admission also depends upon how good your reference letter is. Then you, in some cases, you might have to write the statement of purpose or the research proposal. So if you are already getting into a project which is advertised in the university, they have a clear structure what to do in the project. In that case, you don't need to submit any of the research proposal. And that is also a good thing. If you're applying for PhD, if you see any project openings, apply for it, because they already have the funding for the PhD students and they have a clear-cut idea of what to do, and you don't need to give any research proposal, and it is very easy to get into it, I mean, compared to the usual term. And if you didn't get any project opening, you can directly apply to a professor, but it will take a long procedure because the professors usually receive a lot of emails from people asking for joining for PhD. So in that case, the chances are lower, but still there is chance. And for that case, you have to give your research proposal and research plan, statement of purpose, and so on. And that you will give by mailing directly to the professor. And for if you're applying for a project as a project fellow, there will be a certain criteria for each project, which will be advertised together with it. So this is the usual method of applying. And after applying, they will call you for an interview. It can be either an online interview or person-to-person interview. In that interview, they will mainly ask you to present something you have already studied to see how much you got the idea of the thing you studied. And then they will ask you some simple question like, why do you choose us, kind of the common questions. And after the interview, they will announce the results, and if you are lucky, you will get the. It's good to be. I mean, even if you didn't get it one university, just apply to several universities. Don't be sad that you got rejected from one place. It's not. I mean, it happens. But it's not the end.
Okay. Okay, Rosna, on behalf of the participants, let me ask one more question. Is it necessary to clear any proficiency test in English to get admission for PhD in many countries in abroad?
For abroad, especially in Germany, and I'm in Austria. In Germany and Austria, it is not so compulsory to clear any of the language tests. For me, I haven't cleared any test in English or in German. So here the main language is German. They just ask you to produce a certificate which says that you have studied your master's in an English medium. So that is enough here. But it depends also on universities and places. I think in Canada and USA, you might need to clear the proficiency examinations for English, but it depends on the universities. In some posts, they will clearly say that you don't have to prove anything. You just have to say that you know sufficient English to communicate with them. That's enough.
Okay. Okay, now I think somebody from CUSAT is there. Anne-Marie is there. Anne-Marie?
Hello.
Hi.
Yeah.
Hi, Rosna ചേച്ചി.
Hello.
ഞാൻ ഇടയ്ക്ക് വെച്ചൊന്ന് പോയിട്ട് നെറ്റ് കിട്ടി തിരിച്ചു വന്നതാണ്. അപ്പൊ കഴിയില്ലേന്ന് ഇങ്ങനെ പ്രാർത്ഥിച്ചുകൊണ്ടിരിക്കുകയായിരുന്നു. ഇത് തീരല്ലേന്ന് ഇങ്ങനെ പ്രാർത്ഥിച്ചുകൊണ്ടിരിക്കുകയായിരുന്നു. ചേച്ചി നല്ല ക്ലാസ് ആയിരുന്നു. ഹലോ പറഞ്ഞു.
സർ വീഡിയോ ഓൺ ആക്കാം.
Hello.
ഹലോ. ചേച്ചി ക്ലാസ് ഞാനിവിടെ സൈഡിൽ നിന്ന് വർക്ക്ഔട്ട് ചെയ്തുകൊണ്ടിരിക്കുകയായിരുന്നു. ചേച്ചി പറയുന്ന ക്വസ്റ്റ്യൻസ് ഒക്കെ ഇവിടെ നിന്ന് വർക്ക്ഔട്ട് ചെയ്യുകയായിരുന്നു. കുറച്ചൊക്കെ ഇടയ്ക്കുന്ന് തെറ്റി. അപ്പൊ ടീച്ചർ എക്സ്പ്ലനേഷൻ ഒക്കെ ശരിക്കും യൂസ്ഫുൾ ആയിരുന്നു ഇതിന് വേണ്ടിയിട്ട്.
എന്തായാലും ഇയാള് അത്യാവശ്യം സ്പീഡിൽ ആൻസർ ചെയ്യുന്നുണ്ടായിരുന്നു, ഞാൻ കണ്ടായിരുന്നു ചാറ്റില്.
പിന്നെ ഉത്തരങ്ങൾ തെറ്റി പോകുന്നത് എനിക്ക് കിട്ടാത്ത ഉത്തരങ്ങൾ വരുമ്പോൾ പിന്നെ ഞാൻ ടൈപ്പ് ചെയ്യാറില്ലായിരുന്നു. എന്നാലും തെറ്റിപ്പോയി.
Should we have to switch to English? I don't know whether all the participants are from Kerala.
It is better to
Sorry.
because we have some participants from outside.
Okay.
Okay, I'm sorry.
No problem.
So,
Okay, thank you, Anne-Marie. Rosna, Anne-Marie is okay, actually, right follower of you. She is secured the first rank.
Yes, I saw the status. Yes, I saw your status. Congratulations.
thank you.
Okay. So, any others? I think we can wind up with this. If there is anyone else, we can please come forward. Otherwise, we will wind up the session here.
Mm-hmm.
I think we can wind up. So, as the net examination was on the 26th of this month, we don't have classes on the next weekend. On November 29th, we are having a webinar on artificial intelligence organized on behalf of our WhatsApp groups. We hope that all cooperation from participants for that event. Our next online problem solving session will be on the first week of December with some other resource person. Okay, so we will wind up the session now. Once again, I would like to thank Rosna for the wonderful session on today. And actually, and one more thing, I would like to express my sincere thanks to Vijay Kumar sir. His presence was a really nice experience, not only for Rosna, but for all the participants. Very much, I think he has gone, but anyway, I would like to express my thanks to him. So let us wind up here. Thank you, everyone. Thank you, the participants. Wish you all the very best for all the participants, and Rosna, all the success in your career. Thank you. Thank you very much.
Thank you so much, and thank you so much for the participation also.